Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide, the video series I'm putting together that has a special focus on people who are brand new to Orbiter. In this part of the Absolute Beginner Guide, we're learning how to use TransX, and specifically in this section, we're learning how to go to Mars with TransX. Very important that you already watched the videos on how to go back and forth between the Earth and the Moon, because we spent a lot of time learning just the basics of TransX in those videos. And it's also important, obviously, that you've seen the first couple videos in this part, because we're now, I think this is part 3 for going to Mars. So if you're just somehow finding this video for the first time, we're picking up in the middle of a flight, and it's not going to make any sense. So at the very least, watch the Earth to Moon and Moon to Earth, and then the previous Mars videos. Now, in the last video, we figured out what our best heading could possibly be for the date that we were taking off, and it turned out that we couldn't get a 90-degree heading on this date from our launch site, so we ended up flying at about 50 degrees. So it wasn't the ideal heading. You know, again, ideal heading would be 90, and we kept our relative inclination pretty low on our ride to orbit. Now we just reached MECO, main engine cutoff, at the end of the last video, so now we're ready to pick up from there and figure out what we need to do to actually go to Mars. Switch camera views, and let's unpause. And let me switch the orbit HUD over to orbit mode. Now we're still a little bit low. We're low enough in the atmosphere still that we're getting some trace effect from the from what little atmosphere there is up here. And if I swing that white line directly over top of the green line, can see that our relative inclination is actually starting to go up.
Translation, rotation.
So we kind of want to rotate the other direction now. That'll prevent the relative inclination from increasing, hopefully. Pitch up to the center. Actually, I see what because the nose was below the horizon, that's why. So I need to actually be the other way, but I need to have the nose up above the horizon, or above the center point. And actually, either way, it's going down, but it doesn't really, it's getting worse. It's getting slightly worse, but it really doesn't matter. We're so high up now that there's really no effect from the atmosphere, so we don't have to worry about that. But as always, when we get into orbit, the first priority to figure out, let me switch these over to these, switch the cockpit view over here. When we get up into orbit, the first priority is to always figure out, do we need to circularize or not? And with TransX over here, we can see that we're saying that we're going to eject at that point, and that's only 500 seconds from now. That doesn't give us a lot of time. If necessary, we can actually go around a whole orbit, and in fact we'll probably end up doing that, because I just don't feel like I'm going to have enough time to explain how to set up the maneuver in that little bit of time. So let's skip this eject point, and let's just go circularize our orbit. So we're going to go up to apoapsis, but you can see in a lot of situations you might actually reach the eject point before apoapsis, in which case you wouldn't have to circularize. But in this case, we're going to skip that eject point. We're going to go around one more time, and that's fine too, because our eject date isn't until 57423 anyway. But we could have set it up for this position, or this, first orbit, without going around one time. But we're going to go ahead and go around one time. So we're only 33 seconds away from the time to apoapsis. Let's go prograde. We should probably turn that on a little bit sooner to give the vessel time to settle, but I think it'll be okay. And we only need to raise the other side of our orbit by about 350 kilometers, actually 450 kilometers. So we'll probably wait till the time to the apoapsis is maybe 2 seconds. If we want, we can use a burn time calculator to make our life a little bit easier. Switch over to the time to the apoapsis and do circularize. We started that a little bit late, but that's okay. And now if we look at orbit MFD, we can see that our PEA is 204 and our APA is 205. So we have our orbit's more or less circular. So we don't have to worry about crashing back into the Earth. All right, now we're going to go around and since the eject point's here, we have to go all the way around the Earth one time. Something I want to look for, though, since we didn't get a perfect relative inclination, I want to see where the relative inclination will be, where the lowest point is at. And the lowest point is just like in here. So let me get to that point, and then I'll show something that we might want to do. And it'll change because there are perturbations that happen, and it's going to affect our plane. But what I want to see is, notice it's counting up. And actually, since we're this far away, since we have to go around one whole orbit, let's go all the way around to this one. So we're just going to warp time forward and notice the relative inclination. And it might even go up and then go back down because of the way things work, and it is. That's the case. Now it's going back up. Okay, so we're not quite a half orbit. We're getting... Now I'm just going to adjust the line again. I want to see... So when it gets over to this point, it's basically 0. So let's go forward about that far. Now it's starting to count back up. So in fact, because of the way it's changing, let's actually skip it. Let's go around farther, because it's kind of going up and down. But we don't want to get any closer. Notice the begin burn time. We don't want to get closer than 1500 seconds before we decide what we're going to do on the relative inclination. So 1900, 1800. In fact, let's just go to 1500. There it is. All right, now let's adjust the eject orientation so that that line's straight over top of our position. And make sure it's counting down. Notice the relative inclination. When I go this way, it's counting down. If I were to go that way, it's counting up. So make sure it's counting down. So right now we are, that's how far out of plane we are with regards to our how we want to eject from Earth. But this is counting down, so it's getting better. It's getting closer to 0 as we go forward. But as we talked about in the the moon to Earth, this is counting down. This number here is almost 1 per second. It's not perfectly 1 per second, but this begin burn time is 1 per second. So 1500 seconds from now, we're going to do the burn. So this is actually, if this is about 1 per second, then this is about 5,000 seconds. So what I can do here,
translation rotation,
if I go to the level, get the ship level with the center point, and then it doesn't matter if I'm facing prograde or retrograde as long as I'm level with that center point, I can adjust the relative inclination so that it counts down at about the same rate as that number. So let's do that. Let's get that right over our current position. And since that bubble is filled in, it's going to be normal minus. That means we need to translate down, or we need to press the number 8.
translation.
So we'll go translation mode in 8. And I'm going to bring that down so that it's, instead of 0.5, it's like 0.1. Taking a little while here, and because we're moving in our orbit, you know, we might want to, if this takes a while, we kind of want to adjust that line and keep it. Okay, so we want 0.1, about right here is good enough. Again, this doesn't count down exactly 1 per second. You can see clearly it's faster than 1 per second. So that number to me looks like it's going to match that pretty closely. So what we're saying is that when we get to the eject point, our relative inclination should hopefully be very close to 0.0 all the way across. Now we need to set up a maneuver to go to Mars. We can technically just come around to this point and we can do a main engine burn, but if we do that, it's going to be it's going to be quite imprecise. We would much rather have a maneuver set up to replace our eject plan. And one of the main reasons for that, let me bring up TransX. Our eject plan, when we set it up, we were kind of guessing the date. We don't know exactly when we're going to do the eject. And so we set it for 57423, that, you know, it's that number. So in order for this to be accurate, we would need our MJD to be exactly that number when we get to this point. And the fact of the matter is we have no idea what the MJD is going to be when we get to that point. So what we can do now that we're in orbit is we can set up a maneuver to replace the eject plan. And that's what we did when we went from the moon to the Earth, and it's what we're going to do here. In my old Earth to Mars videos that I did, I always showed the other way first, and then I showed how to set up the maneuver, but I've had a change of heart on that. I think doing it the other way is just wrong. I don't think it's a matter of personal style or taste anymore. I think it's just wrong to do it the other way. So I'm not even going to show it anymore. So on stage 1 on this side, we're going to actually bring up stage 1 on this side as well. So let's go back. And we need to view over to maneuver. And we're going to turn maneuver mode on. Then we're going to press VAR until we have prograde. And we want to put in this number for our prograde, 3.7. That's a pretty high. Actually, what is our best? I think about 3,600, so that's not too bad. So we want to put in this number for our prograde. And the easiest way to do that, again, you can use like that if you want, but it's easier if you just hit enter and then type in 3712. Now you'll note, again, just like when we went from the moon to the Earth, that this hypothetical line is out here, which is kind of odd. But the actual eject point is here. So we want to swing this hypothetical line so that it lies straight over top of that point. It's very easy to do that. Press VAR to get over to the date. And this is only 1,000 seconds from now, so we don't want to adjust the date by a day or two at a time. We want to adjust the date by a few hundred seconds. So we're going to go all the way down to the ultra setting, and we're going to press plus, and notice how that swings around. And we want to lay it basically right over top the other one. Again, it doesn't have to be perfect because we are going to make changes to the date anyway, but get it as close as you can for now. Now that we're really close, we're going to go down to hyper. Now that we're really close, we're going to go all the way to micro. So we are saying that we're going to do our eject at 57422.93. And remember, the plan said that our actual eject date was going to be 57423. It's actually not too far off, but it's still wrong. And if we did if we actually just burned at that point without setting up a maneuver, we would find that our closest approach would be off by thousands of kilometers. We can be much more accurate than that. Okay, so again, view the maneuver, and we've got that. We've got the maneuver date lying straight over top of the same position that the eject plan was. Now we're going to go forward on this side, and we need to get rid of that eject plan. So we're going to view over to the eject plan, and we need to go through each of the variables and reset them. When we went from the moon to the Earth, we only had one variable to reset, which was the prograde, but we actually need to reset all of them. So we're going to go down to the reset, hit plus. Now we're going to go to the next variable, which is outward, and we're going to reset that. We're going to go to the plane change and reset that. And you'll note that once we have all of them reset, we now have a green line here instead of the whatever color the line was before. And you'll also notice that our closest approach went from 11K, like basically the dead center of Mars. Now it's saying that our closest approach is going to be 517,000 kilometers. That's why we set up a maneuver. Now that we're in orbit, we can set up a maneuver to have a much more accurate closest approach. Now on this side, since we changed from plan to maneuver, if we go back to view setup, we can change the graph projection from plan to maneuver so that we have that nice clean look again. And now we're going to bring up the maneuver on this side, stage 1 maneuver, and we want to view stage 2, and the actual view doesn't matter. We want to have stage 2 on this side so we can see the closest approach. Now we need to adjust our maneuver however we need to adjust it in order to bring that closest approach back down, because if we go all the way to stage 3 now and look at our encounter, this is our orbital trajectory out to Mars. We're missing Mars by a ton. So let's have stage 2 for now on this side. And the reason we want stage 2 for now is because if you're missing Mars by more than like 6 or 700 thousand kilometers, you won't even have an encounter view. It won't even show up. So start with stage 2. And again, the view over here doesn't matter because we still have the closest approach. And we're just going to start by adjusting the date, the date of our maneuver backwards or forward, and just see what happens to the closest approach. Does it go up or does it go down? You can see just by moving the time of the burn forward by just a few fractions of a second, it's improving our closest approach dramatically. So that's where we're going to start. We're not making any changes to the velocity. The velocity is the same, but we're just changing the time of the flight a little bit, the time of the maneuver a little bit. Now you can see it's actually starting to go back up, so we're going to go back down and find that lowest point, which is right there at 142. All right, that's as close as we're going to get to Mars if we do nothing other than change the date. And that's a lot better than it was, but it's still not close enough. So let's look at the other variables, and we can pretty much start with any one we want. As you're going around in the variables, it always helps to just hit an update, because you'll notice every time you update, the closest approach will change a little bit, and that's because when you do the update, it's rereading the universe, as I talked about before. So we're going to go to prograde, and course is way too much of an adjustment, so go all the way down to at least ultra, and let's see what adding in a little bit of a little bit more prograde does. You can see that's bringing the closest approach down. It may be though that adjusting one of the other variables is better. So let's check out outward. I'm sorry, let's not check out outward. But once you have the closest approach coming back down using prograde, it can also help to check the date again. See what happens if we go this way with the date. Now you can see we're down to 135 I saw. And let's check the prograde again. Now I'm going to go to super because things aren't moving quite fast enough. I'm going to overshoot this a little bit. We talked about, overshooting variables, so I'm going to overshoot this a little bit. I'm going to take the CL approach out to 200. Now I'm going to check the date again. I'm going to do an update. And notice it's coming down. Now I'm going to overshoot with the time a little bit. I'm going to go out to 200. That's good enough. And we'll check prograde. Notice we're down to 62, so let's go lower. I saw like 52, so let's overshoot again. Let's go out to just 100 this time. And let's do another update. And let's check the date. And now we're down to 34. Okay, so let's overshoot a little bit more. Let's leave it at that. The closer we get, the less overshooting we want to do. Okay, back to the prograde. Down to 21, so we're right there at Mars now. You can see we're only 16,000 kilometers above the surface, but let's get better than that. What we want to do is we want to drive according to TransX, we want to drive our ship straight through the dead center of Mars. Okay, we're at 38. Let's do an update and check the date. Now things are getting really sensitive. Okay, down to 6, so we're just like 3,000 kilometers above the surface. Let's go down to an ultra setting. And now we're inside of Mars, because Mars has the distance between the center of Mars and the surface of Mars is like 3,000. So right now we're about 1,000 kilometers below the surface. Let's go even lower than that. So let's bring that to there and update. Change the date, check the date rather. Yeah, we're already on micro, so we can't do anything else with the date. So the date we're not going to adjust anymore at this point. It's just too sensitive. So we're just going to use prograde, and if necessary, we'll do a little bit with inward and outward and plane change. Okay, now we're down to 644 kilometers above the center of Mars, so we're almost, right into the middle of the planet, and that's exactly what we want to have. We want to get as deep in as we can. So we'll go with that. Okay, now that's good, but as I always say, when we set this stuff up, 500, 600, 1,000 seconds in advance, it'll change. So let's go to view target, and let's get a little bit closer to the time to begin the burn, and then we're going to do an update and see how things look. Okay, we're going to go ahead and warp time forward until they begin burn is maybe 300. Yeah, let's go with let's go 300. I overshot it a little bit. That's okay. And view back over to maneuver and watch what happens when we do an update here. So right now we're saying that we're at 210 kilometers above the center of Mars. We're slamming right into the middle of it. Do an update, and now we're off by 194,000 kilometers. So that's why we do an update. It's very important. Now we're going to go back through our variables a little bit. And again, since it changed so much, we can see what happens with time. And just by making the burn a little bit sooner, we're getting down. And I saw 45 as the low number. So let's subtract a little bit more, go backwards a little bit. Let's go all the way to 75, 90, something like that. And back to, and always update every time you cross update. And it looks like we need to take out some prograde now, maybe. Yep. Okay, that's as low as it's getting. So let's overshoot that out to 100, about there. And update. Check our time. And just back and forth, and you get the idea. So we'll find the lowest point that we can here again. And once we get up to time to do the burn, we'll do it. Okay, it looks like we're going the wrong way with time at this point because things are getting worse. So we actually need to put in some time, overshoot out this direction. Yeah, that's bringing it down. Okay, so a little bit more on the prograde. That might have been too much. Let me go down to a finer setting. And we're getting in there again. So it's a little tedious to do this, but even with IMFD, you have to do this. And I don't really want to cut this part out because if you're brand new to this concept, then you would have no idea how to figure this out on your own. Okay, now we're down to 17, so we're really close to Mars, but we're not going through the center of it like we want. So let's do an update again. Take out some prograde. Do an adjustment on the time. I think I went the wrong way on the time. Let me do that. Let me check how much time we have left. We've only got 100 seconds left, so I'm going to do on view target, I'm going to bring up the auto center and turn it on now so it gets the vessel centered. And then I'll quickly view back over to maneuver and try to clean this up a little bit. If we can't get it perfect, that's okay, because we're going to have to do a mid-course correction anyway. But we would like to at least not start with such a high, not be off by so much from the start is what I'm trying to say. So there we are. We've got our closest approach way down now. That's nice right there. Okay, and I will do a quick update here. That's so irritating. Sometimes I really hate TransX. So clearly, things are changing so rapidly that it's not going to do us any good to try to get it super precise. So it's more important to just do the burn on time at this point. So with auto center on, we're going to begin the burn in 40 seconds. And once the burn is nearly complete, then we'll turn maneuver mode off and we'll do any fine last minute adjustments just using translation thrusters. So again, when you get too terribly close to the time to begin the burn, you can't mess with this anymore because it just changes so fast. All right, let's warp time forward and do the burn here in just a few seconds. 3, 2, 1, and burning, and we're on our way to Mars. And the auto center feature is lovely. I think this is one of the greatest things that's been added to TransX in recent history. It used to be that when you did this burn, as you do the burn, the vessel gets a little bit off center and can even pitch a little bit up and down, and you have to sit there with fine control and keep this X centered, or actually I should say keep the vessel centered on the X is a more accurate way of saying that. and it was really tedious, and it's completely unrealistic. This auto center is not only easier, but it's more realistic. Let's warp time forward to get through the burn more quickly, because 3000 delta V is no short order, even for the XR2. Coming up toward the end of the burn, you want to go back to real time, because the auto center does need, it does do some adjustments on its own, so if you have too much time warp, it'll throw that off. When you get low on the delta V, start getting ready to back off. Okay, we're coming up to 100, so I'm going to start reducing the main engine. 40, reduce it some more. 30, reduce it some more. 20, reduce it some more. And at about 3 meters per second, about right there, we'll kill the main engines. Turn auto center off right away, very important. Now, it's also very important that we quickly change over the maneuver view and turn maneuver mode off. And now we can see what our actual closest approach is.
Rotation, translation.
So with just a little bit of translation,
Rotation.
actually, let's get rotated to prograde. Now that looks like a big scary number, 93,000. But you got to remember, we've got a very long way to go.
Translation.
But with a little bit of translation, we can certainly improve that. And that's the wrong way, so just a little bit of reverse translation in this case. Bringing that closest approach way down. And let's try... Okay, so for whatever reason in this case, about 34,000 is as good as we're getting. And a big part of the reason for this is we're using non-spherical gravity sources, and TransX doesn't behave as well as IMFD does when you have non-spherical gravity sources turned on. But this is still okay. We'll have to do it. We have to do a mid-course correction, period, when we're using TransX. It's just not reliable enough. Even from going from the Earth to the Moon, or Earth to Moon, or Moon to Earth, it's not reliable enough. So let alone when we're going far out into the solar system, it certainly isn't going to hold steady. So we're not going to worry much about that number. And the fact is also, the farther away, once we get away from Earth and the farther away we get from Earth, this will start to stabilize quite a bit more. The reason why it's changing so rapidly right now is because we're still really close to the Earth, and the Earth is having a big impact on our solution, and the Moon is pulling on the Earth. That's another big factor. But once we get away from the Earth-Moon system, this will stabilize a lot more. Okay, so let's pause here and pick it up in the next part. So if you like this part of the video, please do like it. And if you didn't like it, that's okay. Just thumbs down. I'm okay with that. And check for links in the description down below. I'm not sure what links I'll put in there, but I always tend to include something. So check for links down there. And if you have questions, anything like that, leave those. I always answer questions. And then I will see you in the next part. Inclination from increasing, hopefully. Pitch up to the center. Actually, I see because the nose was below the horizon, that's why. So I need to actually be the other way, but I need to have the nose up above the horizon, or above the center point. And actually, either way, it's going down, but it doesn't really, it's getting worse. It's getting slightly worse, but it really doesn't matter. We're so high up now that there's really no effect from the atmosphere, so we don't have to worry about that. But as always, when we get into orbit, the first priority to figure out, let me switch these over to these, switch the cockpit view over here. When we get up into orbit, the first priority is to always figure out, do we need to circularize or not? And with TransX over here, we can see that we're saying that we're going to eject at that heading on this date from our launch site. So we ended up flying at about 50 degrees. So it wasn't the ideal heading. Again, ideal heading would be 90. And we kept our relative inclination pretty low on our ride to orbit. Now we just reached MECO, main engine cutoff, at the end of the last video. So now we're ready to pick up from there and figure out what we need to do to actually go to Mars. Switch camera views, and let's unpause. And let me switch the orbit HUD over to orbit mode. Now we're still a little bit low. We're low enough in the atmosphere still that we're getting some trace effect from what little atmosphere there is up here. And if I swing that white line directly over top of the green line, you can see that our relative inclination is actually starting to go up.
Translation. Rotation.
So we kind of want to rotate the other direction now. That'll prevent the relative inclination. Okay, welcome to another Orbiter 2010 video. And this video is going to be another installment in my absolute beginner guide, the video series I'm putting together that has a special focus on people who are brand new to Orbiter. In this part of the absolute beginner guide, we're learning how to use TransX, and specifically in this section, we're learning how to go to Mars with TransX. Very important that you already watched the videos on how to go back and forth between the Earth and the Moon, because we spent a lot of time learning just the basics of TransX in those videos. And it's also important, obviously, that you've seen the first couple videos in this part, because we're now, I think this is part 3 for going to Mars. So if you're just somehow finding this video for the first time, we're picking up in the middle of a flight, and it's not going to make any sense. So at the very least, watch the Earth to Moon and Moon to Earth, and then the previous Mars videos. Now in the last video, we figured out what our best heading could possibly be for the date that we were taking off, and it turned out that we couldn't get a 90-degree point, and that's only 500 seconds from now. That doesn't give us a lot of time. If necessary, we can actually go around a whole orbit, and in fact, we'll probably end up doing that because I just don't feel like I'm going to have enough time to explain how to set up the maneuver in that little bit of time. So let's skip this eject point, and let's just go circularize our orbit. So we're going to go up to apoapsis. But you can see in a lot of situations, you might actually reach the eject point before apoapsis, in which case you wouldn't have to circularize. But in this case, we're going to skip that eject point. We're going to go around one more time, and that's fine too, because our eject date isn't until 57423 anyway. But we could have set it up for this position, or this first orbit, without going around one time, but we're going to go ahead and go around one time. So we're only 33 seconds away from the time to apoapsis. Let's go prograde. We should have probably turned that on a little bit sooner to give the vessel time to settle, but I think it'll be okay. And we only need to raise the other side of our orbit by about 350 kilometers, actually 450 kilometers. So we'll probably wait till the time to the apoapsis is maybe 2 seconds. If we want, we can use a burn time calculator to make our life a little bit easier. Switch over to the time to the apoapsis and do circularize. We started that a little bit late, but that's okay. And now if we look at orbit MFD, we can see that our PEA is 204 and our APA is 205. So we have our orbit's more or less circular. So we don't have to worry about crashing back into the Earth. All right, now we're going to go around, and since the eject point's here, we have to go all the way around the Earth one time. Something I want to look for, though, since we didn't get a perfect